welcome back to Friday 15. Today's conversation is a conceptual one, so put on your thinking caps for the next 15 minutes. So, my guest today is Beth Eckenrode. She is the co-founder of a Pittsburgh-based consultancy called AUROS Group. And their mission is to provide, I'm going to say it slowly, to provide the full change solution that ensures accountability in a building ecosystem. And I'll ask Beth to explain that for us, but in very simple terms to get us started. So when it comes to sustainability and building optimization, what we often do is put the reporting tools after the fact. So say, for example, you want to optimize your lighting. So you switch out your lights, you put in energy efficient lighting, and then you track your energy bill and you see that you saved energy. So, but the question is it possible to do that type of measurement before the fact, before the systems are installed? So this is why it's a conceptual discussion, because it's a way to rethink the interplay or the marriage between IT, technology, and data science, along with building science, a different paradigm, a different concept. So let's have a quick look at our agenda. So we're going to define this idea of accountability. We're going to look at building upgrades. How can that possibly be bad? This new model, information age meets smart building, and then end off, as usual, with some recommendations and resources. Beth, welcome to the program.
Thank you, Dina. I'm so glad to join you on this Friday 15.
Good. All right. So let's go through that mouthful. Okay. So that full change solution that ensures accountability in the building ecosystem. Explain that to us.
Sure. Well, let's start with what accountability isn't. It's not about trying to find something wrong or figure out if somebody's done something wrong. It's about turning on the lights in order to make sure we make as good decisions as we can on behalf of owners and the ownership team, giving them as much information as they can get in order to reduce risk. And the full chain solution, I mean, as you well know, it's connecting this very long horizontal chain of construction from early design all the way through to operations, right? I mean, that's the building life cycle.
Okay, so full building life cycle means that you want, at the end of it, you want that building to be what?
That's right. At the end of it, we want that building's performance to be understood. And right, exactly, understood. So we turn on the lights, and D'Agostino has a role in that. We'll talk about that a little bit later. But the way we turn on the lights is we basically use physics-based modeling and simulation early in design. And we inform that all the way through that cycle to the very end, when in construction, that context becomes the way you tell if the building is performing as you paid for it to perform.
Interesting. So I want to bring that down to earth, or maybe down to downtown Pittsburgh. Okay, so let's imagine a building on Smithfield Street, big old building. Okay, and you go and you has an older boiler chiller, you upgrade it. So that kind of understanding the building, what was not understood when that building owner upgraded whatever it was in that big building?
Yeah, it's a great question. So looking holistically at a building, it's easy to make transactional choices. Like my boiler's going to go bad. I need to replace my boiler. Or let's get a little bit more efficient boiler in place.
Right.
What we say is, okay, every building has a potential performance it can achieve. That has to be looked at holistically. That's why we use a tool like physics-based modeling and simulation to tell us what the building's capable of doing before we spend money on any single transaction.
Interesting. So in that case of the Smithfield building, how would you go about envisioning that upgrade?
Yeah, so we would potentially still do the upgrade, but we might do other things with it. Like if you're going to go in and touch a building, you're going to renovate a building, we might say, well, 1 + 1 = 3. If you make those same changes to your mechanical systems, but you do some improvement to your envelope, or you start to build in a continuous air barrier, because now you start to change the performance of the whole building. So it's more about looking at things systemically as opposed to transactionally.
Interesting. So that's like information age meets smart building. So that I'm thinking of this systemic model that goes into, and using information technology that goes into that. So what, building that model, tell me about that systemic context. What variables are you putting into it?
Yeah, and again, this is kind of where D'Agostino comes in that you guys are all about connectivity. And for us, in order to think about a smart building, we want to have a smart building, but a high performing building.
Mm-hmm.
So not only do we want a building connected and be able to turn the lights on so a building owner knows in operations how their building is performing, they have control and transparency into their data. We also want to make sure that we can tell relative performance. What's the context to assess whether or not that building met its goals? You know, we can still, Dina, be the only industry in the world that will pay $150 million for something and not know if we got the performance for which we paid. And that's something that the combination of building science and data science comes together in order to answer that question. And it's distinctive in that regard.
And it sounds like it can be modeled.
Absolutely. Absolutely. And again, we go away from transactional models. So there are reasons why you're going to run a certain model to do a certain thing. But that in combination with a physics-based model, which is really about the performance of the building, the combination of those makes sure you don't make the wrong short-term transactional decision. And you're always looking at building performance, first costs, and long-term operating costs, right? With those three things, owners can make much higher quality decisions.
So you're going to put in that model. So there's the actual physics of the building structure, whatever the architect is using to build it. So I guess different materials have different energy usages. You're also going to look at that day-to-day operations intended by the building owner and how that would affect HVAC. Or how that, yeah.
Sure. How many projects have you seen where the building owner said that the programming was going to look a certain way, and then the building comes up and the programming doesn't necessarily look as it was intended? When you've got the type of modeling that we have now, you just take the simulation, you rerun a simulation with a different occupancy structure or a different occupancy program, and you can see if that building is performing the way it should given new assumptions.
Interesting.
That's why having those two tools is so important.
And if I could ask, generally, how accurate is your model at the end? What's your, like, a year down the line?
Yeah, the physics-based models, there are three platforms that exist. IESVE, which is our preferred tool, just because the modules are much more developed and much more advanced. There's Energy Plus, which is a Department of Energy tool, and eQuest. Those are really the only platforms that are physics-based. And they form a new version of a digital twin. So a lot of people are talking about digital twins, right? And there are building information models, right? BIM digital twins. And then there's building energy models, or BEM digital twins. And that's more about performance than just assets in a building.
Nice. Okay. It almost and I have another left field question for you. Okay. So
roll the pitch.
Build a pitch, okay? What's the difference between what you do and somebody going for LEED certification? And I'm saying this from an ignorant place. So LEED, can I just do the list? Is LEED certification, do you end up with the same thing as database modeling?
Yeah, so it really depends on an owner's goals. And LEED is the grandfather of all sustainability programs. It's been around the longest. It really deserves credit for changing the way we think about buildings.
Right.
But what has evolved since then is an idea of, to get to zero energy, you have to really be laser focused on how do you put the right tools and resources and team members together to do things in the proper order and sequence. If you miss that order and sequence, then getting to zero energy is much more expensive, because you're going to be left with a lot more renewables to offset. So we use Passive House Building Science. We use Passive House certification in order to ensure that we are wringing out as much energy consumption as we can possibly wring out. And by doing that, we then offset our move to zero, and offsetting renewables is much easier and cheaper to do. So when anybody's talking about decarbonization of an existing building, it's really that process. And LEED can be helpful, but there's so much more to LEED. Maybe you need it, maybe you don't. Maybe you want the certification, maybe you don't need it. If you're really trying to get to a decarbonized existing building, the most laser sharp way of doing that is Passive House Building Science.
Right. And plus all the other, like the operational model that you're building into it, which is just
Yes.
more than just the physical structure. It's the
Yeah.
actual usage, that the ultimate usage of the building. And what I love about this idea is it's I always like think it's like a paradigm shift in how we use IT in buildings. A little similar, like a Tesla car is made differently because we have this future in mind in terms of transportation. So information age meets smart building, we have a different future in mind, one with the decarbonization. We have to update our tools. And
Absolutely.
yeah.
And this space has moved so fast. And
Yeah.
IT has really kind of hit a bit of a renaissance. Like, it's
Interesting.
so important to consider how you bring together all the data inside of a building, and you do it in a way where owners can not only have access to it and manage it, but own it.
Right.
And how to think about building the right data structure in a building is as important to do in early design as planning your, your architecture and your basic engineering. We do all of that data work very early in design because it's so consequential to everything we want to do in operations.
Yeah. So it sounds like your best customer, somebody who wants visibility, wants accountability. What drives them? What makes somebody want that in the first place?
Well, I think it's having tripped and fallen. And a lot of times people think that tripping and falling or failing is just simply failure. It's not. It's the next step to success, right? And so in our world, what we're looking for are the clients, the developers and owners that have fallen. They know what they don't know. They're now aware enough to say, I have to bring somebody in to do this work and to help me think about this very early before I even potentially constitute a team. And so that is really our best customer, are the ones that have fallen enough times to know I can't do this on my own. I've got to figure out how to bring the right talent pool together in order to get to that result in operations and build that early in design.
Right. And do you see legislation kind of forcing people who are ambivalent?
Most certainly. Yeah, most certainly. And if our ecosystem of practitioners wasn't sharp enough, I'd be really worried about it. But in the greater Pittsburgh area, Western Pennsylvania, West Virginia, Ohio, New York, in that whole region, we've got deep enough practitioners in every segment of the construction chain, whether it's the sustainability folks to the engineering teams to the architecture teams. We've got ecosystem here that it can rival any area, which is why Pittsburgh leads with a lot of other cities when people might not expect it could lead in this area. Our not-for-profits are aligned. Our universities are aligned. I mean, we have so much talent and resources here in Pittsburgh that it makes us really ripe to do this work. So we should not be at all fearful of any local law 97 or BERDO or anything else, because we've got the capabilities here to do that work.
Yeah. And in the end, you come out with a building that is saving you money, saving the planet, aligned with your values.
I'm glad you brought that up. I mean, I say to people all the time that it's an interesting situation we have, because it aligns so many of our generation's most gnarly problems, right? Whether it's environment or it's social equity, in terms of reducing fuel poverty, driving equitable indoor air quality. All of these things align that if we fix the decarbonization problem, everything else can come with it. And I just haven't seen that very much in my lifetime, where we can hit a bullseye and tackle so many things at the same time.
Nice. Okay, so we're going to end off with some resources and recommendations. I'm going to add this. This is AUROS. This is Beth from Beth Eckenrode, co-founder of AUROS. The QR code will take you to the website. They have a book if you really want to get your thinking cap on. And Beth, any final words?
Right. I mean, to this ecosystem in particular, like, don't be deterred, whether it's a really nasty old building or it's a historic preservation building. We've had some success in New York on historic preservation buildings getting passive house certification under the EnerPHit strategy, under the EnerPHit certification and standard. Whether it's trying a new tool, taking a new approach with a team, open yourself up to what's possible, because everybody around you is ready to jump in and help and get us to where we need to go. So just don't be deterred. Take the step forward.
Thank you very much. And we'll sign off here until the next time. Thank you.